In this video, we will solve a Charles's law balloon problem and visualize it. The context is this. Charles planned a hydrogen balloon flight, but instead of a warm month, imagine the launch happens on a cold January day at negative 10 degrees Celsius. At the same pressure and with the same amount of gas, how large must the balloon be? We'll answer that using Charles's law and show a clear diagram comparing a warm day to a cold day. Let's draw two side-by-side panels. Left will represent a warm August day, and right will represent the cold January day at negative 10 degrees Celsius. We will add a ground line, two panels with labels, and then place a balloon icon in each panel sized according to the absolute temperature in Kelvin. We'll use 25 degrees Celsius for a typical warm August ground temperature. If your earlier example used a different August temperature, just substitute it. Now we add the balloons, one for August and one for January. We'll scale the January balloon by the ratio of temperatures in Kelvin. At constant pressure and with the same amount of gas, Charles's law says volume divided by absolute temperature is constant. That is, V over T equals a constant. So between the August and January states, we have V sub August over T sub August equals V sub Jan over T sub January. Solving for the January volume gives V sub Jan equals V sub August times T sub Jan over T sub August. Now, let's plug in the temperatures in Kelvin. V sub Jan equals V sub August times open parenthesis 263.15 over 298.15 close parenthesis. That ratio is approximately 0.883. So, at the same pressure with the same amount of gas, the cold day balloon volume is about 88% of the warm day balloon volume. If your earlier example provided a specific August volume, just multiply that volume by 0.883 to get the January volume at negative 10 degrees Celsius. To build intuition, let's quickly see why this makes sense. At constant pressure, volume is directly proportional to absolute temperature. That is a straight line through the origin in a volume versus temperature in Kelvin graph. So lowering the temperature lowers the volume by the same factor. Summary: at the same pressure with the same amount of hydrogen gas, the balloon volume is proportional to absolute temperature. Using 25 degrees Celsius for August and negative 10 degrees Celsius for January, the Kelvin ratio is about 0.883. Therefore, the January balloon volume should be about 88% of the August balloon volume. For example, if the August volume were 1,000 cubic meters, then the January volume would be roughly 883 cubic meters. That is how we use Charles's law to size the balloon on a colder day, using only the temperature change in Kelvin.